Hi guys, welcome to my channel. Today we'll be doing a practice with you. We'll be investigating an incident, an alert created on your SOC environment. In our case, in our scenario, your DNS security solution tagged a domain as newly registered and you start the investigation. Many of you should approach this alert as highly malicious because most of the time attackers use newly registered domains. On alert details you have only the domain name and the source IP address which queried the domain. While you're investigating, you found out that the last user who logged on and got the machine infected, after opening his mail and start doing the business, the malicious document has the malicious document's hash is nowhere to be found on VirusTotal, Hybrid Analysis, and your popular sandboxing tools. So on your static analysis, you get nothing with file fingerprinting, and it is best to get the malicious document and analyze it in a sandbox environment. On our investigation, we will extract IOCs related to the malicious document and continue the investigation, and maybe try to threat hunt in your environment. So I used a sample. I found it on any.run. It is a automated sandbox environment. I downloaded it, and in my lab I am using Remnux, and I'm using a Windows 10 machine. I actually downloaded the FlareVM PowerShell script and installed all the applications to reverse engineer and analyze malware. So as you can see, I cannot get into the internet. It is isolated. I'm running procmon process monitor to monitor the process activities after running the malicious Word document. And I'll be using Wireshark to get a dump of the network traffic, a PCAP file. And on Remnix, we'll start slow with olevba. Olevba is a script to parse VBA objects in XML or Office documents. So let's start. Its usage is very basic. You just write olevba and the file. So the file here is rep. It is always a good idea to start your analysis with static analysis. It might lead you where to look at in your dynamic analysis, like when you monitor the registry activities or the network activities. The static analysis findings may lead you to the right path. So olevba.rep document. Let's see. On the bottom, it is giving me a view, so it is suspicious. It may execute commands through VMI, Windows Management Infrastructure, and it is suspicious the keyword is show window, may hide the application. So when you open the Word and you accept the VBA macros, the macros and the PowerShell command will run on background. You will not see the pop-ups or windows. So it is saying it is using a get object. It may attempt to obfuscate specific strings, and it has base 64 strings. Okay. So it has extracted the macros inside the Word document. You may try to deobfuscate, but it is always a good approach to run a dynamic analysis, because here you get only random characters and not much to look at. Because the constants are very random chars. There is no domain, there is no HTTP. There are other loops. These may be junk codes. You may not know this, but malware writers do that approach often. They apply junk code and let's see. So that's the end. So we know that this document has base 64 encoded commands, and it may hide the application. It may run PowerShell or CMD commands in background, and it may execute VMI commands. So in our dynamic analysis, we'll be focusing on this subject. All right. So let's continue without saving. And I just started the Wireshark from my Remnux machine. And let's run the inetsim command. Inetsim starts services, common services on Remnux, because malware tries to connect to the internet, and sometimes it checks some domains, some URLs. After that, if it gets 200, like 200 response, it will make a query to the actual malicious domain. So SMTP, HTTP, and FTP and POP3S, all of that are running right now. But there is no DNS server, so let's apply that with fake DNS. So this is running as a DNS server, and when my Windows 10 machine makes a query, it will make a response. So on Remnux, it is good to go. Let's go to the detonation zone. Now let's hit a zip. Okay, This is our malicious document. So I want to open another Wireshark here. You'll see that in the end. One is administrator. Because with Wireshark's output and the process monitor's output, I will give these findings to procdot and it will give me a map. So let's clear the cache, and I will also, let's start our Wireshark, our process monitor. I'll start procwatch just for fun, and let's open our Word document. Okay, you can see that it is actually running, and there's a VMI call. And there's a command line here. Okay, let's enable the content. So what will happen now? So the malware user ran PowerShell here, but we did not see a PowerShell command, a window. Let's see, anything new coming? I think it has done its job right now. Let me think. Let's click somewhere. I think that's it. So let's stop the process monitor and our Wireshark. And let's go to our Remnix machine. Why there is no DNS queries? Let's go to the pcap file. Let's apply a filter. DNS. Maybe our fake DNS did not work as intended, but on our Wireshark output we can see that the malicious domains olevba.com, beach.org, aeonschools.com. Okay, so we are in the business. That's okay. That is just okay. So Let's export, save as this. So let's run our procdot. Okay. And this is the network traffic. Okay. On procdot, it is looking for .pcap, so we need to make sure this is the right extension. Save it. Okay. Okay, I think it did it. And let me close the document. So on procwatch we saw VMI call because the process has been ran, and we saw PowerShell, so some commands should be ran on background, and other than that these are not related. Okay, we'll be focusing on PowerShell VMI calls. All right, let's close this and let's go to desktop, network traffic.pcap. So our procmon, save. I think it wants the CSV extension, right? Okay. Yes. It's gonna take a while. So on dynamic analysis, you should review disk, network traffic, registry, and what I mean by disk is what is created, the file. On network, I'm looking for an IP address, a network connection, or a domain resolve, a malicious domain. And on registry, I'm looking for persistency methods used, like creating a key in current version that ran hive in registry. Okay, so I think our procmon is alright too. Let's give that. So this is the new one. Okay. Let's refresh. So procdot is a handy tool. I use it oftenly. Basically, you run procmon, procmon and Wireshark and give this output to procdot, and it will give you a map for you to see easily what the malware does. You can always open a process tree, clicking to process monitor here. We will see procdot output later. Let's start. So you can see that under service host.exe there is a process called VMI preserve.exe. It is signed Microsoft Corporation, portable executable, and it has run a obfuscated PowerShell command. You see, can we copy that to here? Great. So we see that VMI preserve exe, and the child process is PowerShell.exe, and it has run this encoded command. Let's go to the start. It is running hidden, and it is using a -en, which means encoded, right? Encoded. They are using en because on PowerShell en, enc, or anything is similar. So let's look at other processes. We will look at procdot, but it is good to know that you can analyze a malware just with process monitor here. There is another VMI preserve.exe. Let's go bottom. There's a command line. I think this is an older one. Okay. It might be the command line which I opened very early. Let's go to the bottom, and our procmon, Wireshark dump cap.exe, WinWord. See, it is just opening a document. All right. What we have here is base64 encoded PowerShell command. Okay, let's close the process monitor's process tree. And let's see what procdot gave us. I did not click the excel.exe, so I didn't give him the process to analyze. So while he's doing that, Okay, let's go to CyberChef and deobfuscate this. As input, this is the base 64. From base 64, so let's get that output. It is not looking as good as so let's delete this. So it is not double base 64 encoded. Let's remove this and let's remove the null characters here. Did it work? I think we can do that on our notepad. So let's remove the dots. Come back. Why is it going? So this constant is gibberish, but we can see environment, user profile, blah 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 blah. There is a new object. Let's change that. Why? Oh, it is looking. Sorry. Okay, it is looking much better. I think so. There is actually 1, 2, 3, 4, 5 URLs encoded here. So let's delete that. .NET Web Client. So it is giving these URLs and split after that for each. I think this constant is using recursively here and here. Download file, blah 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 blah, get item. Okay, after that it starts a process. I think if get item, this constant length is bigger than 25,859. Okay, we only need this URL. So let's go with this. So on every URL it has the star, because on code it is split with a star. So I'm gonna delete that. So these are the URLs. These are the IOC, network IOCs. Let's go to procdot and let's refresh. We already got the network IOCs, but it is good to look again. Maybe we'll find another. So on pickup it found amyleno.net. This is yes. 911 concept here, firelabel.com here, beach.org here. It doesn't, they don't have the dot sign because I removed earlier, that's my fault, but other than that I think we are okay. I don't think it is working. Oh, there is so much going on here. I think this is related to me because I opened the PowerShell transcript logging on this computer to analyze the PowerShell commands. So it has thread to this. Okay, I think we can go there and look for ourselves. And see users, this PC. So let's open the PowerShell transcript logging. So there it is, the encoded PowerShell command. I opened the script log logging and transcript logging to ensure that I'm covering all the artifacts. After that command, there is another constant. It is creating this environment, user profile, and these are the malicious URLs that the document tries to reach. Okay, let's look our procdot. I love this tool very much. So it has interacted with these registry hives a lot of. But let's see if any persistency mechanism is shown. So it created these temporary files and trust records. Let's see. Usage VBA files. Current version installer. Potential data loss info. Let's get the bigger picture because it is a lot here. These are the threads that it created. It is looking for file activity. Where is the end of this? Sometimes you get a lot of output and you're just lost in data. Okay. So on our analysis, there isn't any malicious activity other than that these network ISCs. The malware will download another malware from these URLs and it will execute it. But since it cannot get a response from these URLs, we may not go further with our investigation. So let's close the procdot and our other services, and let's go to the snapshot 3 to analyze malware for later. Always take snapshots, it helps a lot. So we analyze the malicious Word document. You may not want to do this on every case, but now you know how to do it on manually. You can now do and use automated sandbox environments or tools. One tool I often use is the DocGuard. DocGuard.io helps you detect malwares in Office documents in seconds. So here I will detonate the malware. It is somewhere between static and dynamic analysis. They're saying this as structural analysis tool. So we gave our password and let's analyze the file. So it gave us the verdict as malicious instantly. It mapped this attack malicious as initial access and execution. It is using a blacklist API. Let's go to MITRE attack. So it is saying that it may be phishing and it has scripting language details. Let's go to the IOCs. There is macros, which we found earlier. Okay, it has the enable content. Since this macro is obfuscated, it did not give us the URL or domains, I guess. But in 2 seconds, it said that this is a malicious document, and you need to analyze it. So it extracted the macro here. What we can do is we can go to any app that's run. And start a new task. Run it. And let's give the password here. Let's open the document. So we see that it never asked about macros here and made connections to these URLs. Obviously these URLs are down most of the time because this malware sample is older, maybe than a year, so these domains may not be used by malware from now. So we get the file label, beach.org, and all the network ISCs we found on our manual analysis in sandbox environment. I think that's it. Well, that's not it. So while we are working in a SOC environment, we get these IOCs, and our investigation is not finished yet. We have to write a report. These are the artifacts, and let's escalate this to level 3 or level 2 in your case, because this is a serious event. Positive, true positive. I'm not writing it. True positive. Okay, thanks for watching, guys. I'll see you next time.